The first and most important type of factoring is factoring out a GCF, which stands for greatest common factor. So when we want to factor a GCF out of a polynomial, what we're going to do is we're going to look at the individual terms, and terms are separated by pluses or minuses. We're going to look for what is the greatest common factor between those two terms. So for the number part of this is just looking for what's the largest number that will divide evenly into both of these numbers. So in this case, 21 and 14, the largest number that goes into both of those evenly is 7. So 7 would be my GCF here. And then you look at the variables as well and see if they have anything in common. In this case, my first term has an x, but my second does not. So there is no variable term in my GCF. So our GCF is 7, and we'll write our GCF out front. And then in parentheses, we will write what's left when we take out that GCF. And often we say that we're taking it out or we're factoring out. But really what we mean is we're dividing it. So we would take each term and divide it by that GCF. So 21x divided by 7 would be 3x. And then take the other term and do the same thing. So 14 divided by 7 would be 2. It's positive. So this is going to be plus 2, and we'll end our parentheses. And that is our factored answer. And the nice thing about any factoring method is that you can always check your work. So in this case, if I wanted to just distribute that 7 inside the parentheses, 7 times 3x would give me 21x, and 7 times 2 would give me positive 14. So I can always check and see that I get back to what I started with. So if we go to this one next, let's look for the GCF in these two terms. So between the 3 and the 21, the number part of this, 3 would be my GCF because 3 goes evenly into itself and also into 21. But in this case, there's also some variables in my GCF. So there is an x here, but there is no x in my first term. However, I do have some z's in common. So I can see my first term has 1z, and then my second term has z to the fourth, or basically 4 z's. So that means that they would have 1z in common. You can also think of it as the smallest number. So if one of them has 1z and the other one has 4, how many do they have in common? They have one of them in common. So my GCF here will be 3z, and then I'm going to write what's left when I factor that out in parentheses. So 3z divided by the GCF of 3z would be 1, because anything divided by itself is 1, and you need to write that 1. So then negative 21xz to the fourth, divide that by 3z. So let's just start with the numbers. Negative 21 divided by 3 would be negative 7. And then there's still an x here. And then z to the fourth divided by z would be z cubed. And you can think of that as technically this is z to the first. We just don't normally write that exponent there. So when we're dividing, we subtract exponents. So z to the fourth divided by z to the first, subtract 4 minus 1 and you get 3. Or you can also just think of it as z to the fourth as being z times z times z times z. And if you divide that by z, one of them cancels and leaves you with z to the third. So, and then I'll just end my parentheses, and I don't need that exponent on the z. It's not going to hurt anything, but I don't need the 1 there. And that's it. I could distribute that to check my answer. So this next one has 3 terms. So looking for the GCF, I'm looking for what all 3 of these have in common. In this case, I can factor out a 3, but I can also factor out an x. So the first term has 1x, the second term has x squared, the third term has x cubed. So if there's 1, 2, and 3 x's, then they all have at least 1 in common. So I'll divide by that. 9x divided by 3x would be 3. 3x squared divided by 3x would be x, and it's positive. So I'm going to write that as plus x. And that's basically because the 3 divided by 3 became 1, and then x squared divided by x is x. And then negative 6x cubed divided by 3x would be negative 2x squared. And that's it. That's my factored answer. All right, so then on the next one, again, we have 3 terms, and I'm looking for what do they have in common. So just starting with the numbers, the largest number that will divide evenly into all 3 of these would actually be 4. So 2 would be a common factor, but you're looking for the greatest common factor, and 4 will go into those. In terms of my x's, they all have at least one x in common. And in terms of my y's, they actually all have at least two y's in common. Because I've got y squared, y cubed, and y squared. So I would pick the smallest of those. All right, but this is not quite done. So this is one of the tricky things with math that says if your first term is negative, that's considered bad mathematical form. So we don't have a problem if any other term is negative, like earlier where we had negative 6x cubed, or where we had negative 21xz to the fourth. But if your first term is negative, we don't like that. We say that doesn't look good mathematically. So that means that whenever your first term is negative, we're actually going to factor that negative out with the GCF. So in this case, my GCF is not just 4xy squared, it's negative 4xy squared. And then I'm going to divide everything by that. So take the first term and divide it by the GCF. So negative 4xy squared divided by negative 4xy squared is just 1, because anything divided by itself is 1. Then negative 16xy cubed, I'm dividing that by the negative 4xy squared. So negative 16 divided by negative 4 would be positive 4. The x divided by x basically cancels or becomes 1. And then y cubed divided by y squared would just be y. And then my last term, if I take 8x squared y squared and divide it by that GCF, 8 divided by negative 4 is negative 2. X squared divided by x is x. And y squared divided by y squared is just 1. And if I multiply it by 1, that doesn't change it. So I don't need to write that 1. And that's my answer there. Then looking at the last couple here, these look a little bit different, right? So, but we're still going to factor out a GCF. Remember that when we factor out a GCF, we are looking for the greatest common factor among each term. And we said that terms are separated by your pluses and minuses, right? So on this one, we can see that there's a plus sign here. So that's going to separate our terms. And we're also seeing some minus signs, but the minus sign that we're seeing is actually inside of a parentheses, and that parentheses here stands for multiplication. This is really x times that whole thing in parentheses. So really, this is all one term. Since it's multiplication, that's all one term. Then the plus sign would separate this from this is actually all one term. So even though this looks a little different, it only has two terms. And so I'm looking for the greatest common factor or what they have in common. And what they have in common is actually the part that's in parentheses. They have a y minus 2 in common. And I'm going to include the parentheses on that. So what we've been doing each time is we've been factoring out what they have in common. We've been writing that out front. And then in parentheses after that, we've written what's left, right? So think of this as just division again. So if I were to take this first term, right, x times y minus 2 and divide it by my GCF of y minus 2, y minus 2 over y minus 2 is just 1, right? It cancels. And 1 times x would just leave me with x. And then I'm going to do it very similarly here. So if this is going to be 3 times y minus 2 and divided by y minus 2, it's just going to leave me with 3. So it's a little different, but it's the same idea. We're just taking whatever they have in common, factoring that out front. And then if you were to cover that up, I'm going to cross it out just for a minute. So if I just use my fingers to cover that up or cross it out, I'm left with x plus 3. So then let's do the last one. This one, again, has a GCF of y minus 2. And so think about this as division, right? We're going to divide each of these terms by y minus 2 and then write what's left. So if I take x times y minus 2 and divide it by y minus 2, anything over itself is just 1. 1 times x would just leave me with x. And then on the second part here, if I take this term of y minus 2 and divide it by the GCF of y minus 2, anything over itself is 1, in this case, plus 1. And so this would be my answer. Once I factored out the y minus 2, that left me with x plus 1, and that's my final answer.